Okay. Today we're going to be going through some more stoichiometry notes. This is on the back side of the notes that you took yesterday. Keep in mind that we already know how to convert from grams to moles and from liters to moles. So we're going to be using those skills today. The mole pathway. The mole pathway is how we get from one substance to another substance. You already know how to get from, say, grams of substance A to moles of substance A, or from liters of substance A to moles of substance A. And you know how to go the other direction. If you're given moles of a substance, you know how to convert to grams, or you know how to convert to liters of that substance. Yesterday, you learned this middle section here, how to go from one substance to another, to go from moles of substance A to moles of substance B. And we're going to be putting this all together now. So let's take a look at some problems here. How many moles of iron 3 oxide are formed when 17.4 grams of iron react? Well, we're starting with grams, so we're starting here on our mole pathway. Our first units are going to be grams of iron. From grams of iron, we can create a conversion factor, take us to moles of iron. From moles of iron, we learned yesterday how to go to moles of a different substance. We're interested in iron oxide, iron 3 oxide. So from there, we can go to moles of iron 3 oxide. I got that glare again. Okay, that's better. So this is the path that we're going to be taking. This is the mole pathway we're going to follow. These are the units that we're going to need. And these will be the units on the top of our conversion factors then. So let's write the problem. 17.4 grams of iron. And we're going to create a conversion factor that takes us to moles of iron. From there, we're going to create a conversion factor that takes us to moles of iron 3 oxide. Iron 3. Sorry about that. Iron 3 oxide. In order to create our conversion factors now, this unit comes down here, this unit comes down here, just like we were doing in the past when we've done conversions. The order of the bottoms of the conversion factors will be exactly this order, but it'll just be bumped over a space. So grams of iron, moles of iron, moles of iron 3 oxide are the units on our answers. Okay, now it's time to put some numbers in there. 1 mole of iron is 55.85 grams. Where did I get that number? I got that from the periodic table. Now I have moles of one substance and moles of another substance. This is my mole ratio. So I have to go to the balanced equation to get those numbers. 2 is the coefficient on iron 3 oxide, so 2 moles of iron 3 oxide for every 4 is the coefficient on iron for every 4 moles of iron. So check your units, cross them off. I have grams of iron on the top here, grams of iron on the bottom there, they cancel. Moles of iron on the top here, moles of iron on the top here, they cancel. Moles of iron 3 oxide is what I have left. Moles of iron 3 oxide will be my answer. Moles of iron 3 oxide is what we were asked for. So now it's just time to put the stuff into the calculator. 17.4 times 1 divided by 55.85 times 2 divided by 4 gives us 0.156 moles of iron 3 oxide, rounded to 3 significant digits. The next one. How many moles of iron are needed to completely react with 8.92 liters of oxygen gas at STP? So we're starting with the units, liters of oxygen gas. Well, we're entering our mole pathway right here. Liters of substance A, which is oxygen gas. From there, we can move to moles of oxygen gas. From moles of oxygen gas, we can go to moles of any other substance in the equation. In this case, we want iron. It's asking us about moles of iron. Okay. It didn't ask us to take it all the way to grams or liters, so we're done on our mole pathway when we get here. Moles of substance B. Moles. So now we need to write our equation. We have 8.92 liters of oxygen. We need to write a conversion factor then that will take us to moles of oxygen. From moles of oxygen then, we can convert to moles of iron. The bottom of our conversion factors, we will have liters of oxygen. Here we will have moles of oxygen. Here, for the answer, we will have moles of iron, which is what the question asks us for. Time to put some numbers in here. 1 mole of oxygen contains how many liters? 22.4. A mole of any gas at STP contains 22.4 liters. Moles of iron and moles of oxygen. I have moles of 2 different substances in my conversion factor. That sends me to the a balanced equation for the mole ratio. Moles of iron, 4. Moles of oxygen, 3. Okay, cancel my liters of oxygen, top and bottom. Moles of oxygen on top, moles of oxygen on the bottom. Moles of iron is what I have left. Okay, now it's time to put the numbers into the calculator. 8.92 times 1 divided by 22.4 times 4 divided by 3 gives me 0.531 moles of iron, rounded to 3 significant figures. Here's another equation. Okay. C3H8 plus O2 gas yields, it doesn't give us the rest. However, we recognize that adding oxygen gas, we have carbon and hydrogen here, we have a combustion reaction, so we can finish that off. We know that the products are going to be carbon dioxide gas and H2O. Probably comes out as a gas, but pretty quickly forms back into a liquid. Now, we need to balance our equation. 3 carbons here, so I want 3 here, 8 hydrogens here, 2 times 4 is 8. Now my oxygens, I have 2 times 3, I have 6 oxygens, and 4 oxygens, 10 oxygens, so I need 5 O2s, 5 times 2, 10 oxygens on that side. Okay, so now some questions using that balanced equation. How many moles of carbon dioxide can be made from 2.8 moles of propane? Well, I look at my mole pathway, and I'm starting with moles of one substance and going to moles of another one. So I don't need this portion of it or this portion of it. I just need that center section of the mole pathway. So I'll be going from moles of C3H8 to moles of carbon dioxide. So 2.8 moles of propane. Write a conversion factor. Moles of carbon dioxide will be the top of that conversion factor. Moles of propane comes down and becomes the bottom. Now, I have moles of one substance, moles of another substance. That sends me to my balanced equation. Moles of propane, there's nothing there, so that's 1. Moles of carbon dioxide, 3. My moles of propane cancel. Moles of carbon dioxide is what I have left. So now I just put the numbers into the calculator. 2.8 times 3 divided by 1, 8.4 moles of carbon dioxide. Two significant digits. There I go. How many moles of propane are needed to form 14.7 grams of carbon dioxide? So they're giving me number of grams of carbon dioxide. From there, again, starting here, grams of carbon dioxide, I'm going to go to moles of carbon dioxide. From there I can go to moles of propane. Okay, so let's write out the equation then. I've got 14.7 grams of carbon dioxide. I want to write a conversion factor that will take me to moles of carbon dioxide. From there, we will go to moles of propane. The bottom of my conversion factor, grams of carbon dioxide, moles of carbon dioxide, moles of propane. So, some numbers now. 1 mole of carbon dioxide contains how many grams? Well, I'm going to have to figure out the molar mass of carbon dioxide. Carbon and oxygen, I have 1 times the mass of 12, and I have 2 times the mass of oxygen. 2 times 16 plus 12 gives me 44.0 grams per mole. So 44.0, got my decimal in the wrong place there. 44.0 grams in every mole. Moles of propane and moles of carbon dioxide, moles of two different substances in the same conversion factor, tells me that I need to go to the balanced equation. Moles of propane, 1. Moles of carbon dioxide, 3. Cancel my units. Grams of carbon dioxide on the top cancels grams of carbon dioxide on the bottom.